Hi guys, welcome to another video. So, previous video we are trying very hard to see if we could get the locator to behave and use the new properties, the new stuff that we put in, mainly the project path properties. But as we went along we found out problems and we figured out that there's some data elements that were not in the right places. So we went on a merry go around fixing those things. And now, hopefully, we're back to where we want to be. So what we'll do is, we now remember where we were, and we remember that we're not supposed to touch this model, so it's fine, we can touch it now. And we should be able to continue where we left off. Actually we have some changes in the physical model. These are just cosmetic changes, so what we'll do is we'll just quickly unstage all of this stuff. There's really nothing here other than just moving types around, so I always like to make these commits clean commits. I know there's nothing there, so cosmetic keyboard, cosmetic changes, physical model, minor. And that's just so that we know that there's nothing special going on there. Now then, back to locator, our lovely friend. What we're going to find out is in locator we had problems locating, I guess, bit of a pun there, locating some properties that had to do with facets and so on. So here we are, the archetype properties are here. And we are trying to locate the configuration for an archetype. I mean, we could rename this to something like properties for the archetype, but it's fine. And once we got these guys, interestingly enough, it's not clear to me why we still need the configuration for archetype. Right, so I think there's a problem here. Let's have a look at what configuration for archetype is doing. This should be doing a lookup. Yeah, okay, so let's just start off by saying that configuration for archetype is archetype properties for archetype. So given an archetype returns its properties. I mean, these names, configuration properties, I mean, I really am not a big fan of either of these names, but we just have to bear with us as we go through the model to the discovery of this domain, and then at some point hopefully we're going to find the right names for things. So really what we should be doing here is to say don't bother with all of that. We already have an archetype here, so let's just say slightly confused at the moment. So what are we trying to say? An archetype properties for archetype, which is this guy here. You give it an archetype, it will look for that properties. If it doesn't exist, we will get upset, so that looks fine. So seems to me we're doing the same thing twice. So let's just say don't bother with any of this, just give me the archetype properties for the archetype. And then on the archetype properties, if we have a facet and it's got a directory, computer directory name, and if it's empty, right, so this is now equivalent to that. And then interesting, so disable facet directories. Okay, so this is going to be very slow. We move by 1 inch and then we have a problem. Disable facet directory. So do we have disable facet directories anywhere? No, we do. It's a project path thing, so that's fine. So for that we will need physical model if we just say something like post auto by reference. So let's go to PPP presumably, and then we can just say something like physical model dot project meta model properties dot project something or other, project path properties. Right, this is a bit too big, so let's get the MMP out of this guy. P. Yep, so the NMP, you get the project path properties. The project path properties will tell us how to disable the Facet directories. And then here we can just say Facet properties dot computed directory name. And you see we've just replaced the very first bit. This is not fast, but now then, archetype properties, archetype postfix, so presumably this is going to be something like computed postfix dot empty, and then the facet postfix will be something like ap.facet properties dot computed postfix, presumably. It's empty. And that should give us this method, so that's good. Now, I suspect we're going to have, I mean, there's a lot of hackery going on here. You really have to bear with us. Suspect we're going to have a lot of similarities between that method and this one, so let's just grab a few things. There's the archetype property, so we know we don't need a configuration. Okay, this seems like we did a copy and paste from this method to the other, but of course there will be very, very slight differences. This is the annoying thing about these things. So we have to make sure when we copy and paste, we don't break the world. So that looks the same. And that looks the same as well. These are all historical things that are here for a reason, but it's unlikely we'll remember what that reason was. But all this code is about to be refactored, so it's not a problem. Right, so then we keep going, okay, next problem. Okay, now all of these will be very, very straightforward. We just need to get access to the PPP. And the PPP we shall give us what we're looking for. Which is good. So as I said before, I mean, you probably are thinking, wow, this is a bit long-winded way of doing things. I mean, we know this code is all going to get removed. Why bother with all of this? And it's really tempting to just not to do that, really. And to be honest, we go through this phase a lot, where we go through a bit of pain, and then we think, oh, there must be an easy, quicker way of getting this done. And then what tends to happen is, almost always, you end up taking a lot longer. Because as you can see, what we're doing here, it may look boring, but it's actually quite straightforward. This does not require a huge amount of thinking. If you try to do meta-model programming, you will see that you almost got the exact opposite problem. It is quite hard. So configuration for Facet will undoubtedly be similar to what happened to the archetype. So archetype properties for Facet. No, Facet. And that then means that this guy changes and this guy changes. So just need the Facet properties, and then in the Facet properties we probably want the computed postfix, presumably. And yeah, so whilst this is really not nice, it is much easier than tackling the problem in one go. And what is good about things that are boring, I guess, is just that they don't really require a lot of thinking. You can just do it mechanically. So what is the problem with this? Make project path. I think we needed something else in project path, didn't we? Oh, the output directory path. Oh, I see. So we seem to have... Right, so it's just a typo. Okay, so... right, so then, configuration for Facet. Well, we know that doesn't exist, so... we need to call the Facet properties with Facet. And then the directory is part of the Facet properties. Computer name that empty. Right, so now we just need access to the PPP. And are we recording? Yes, we are. And then in the PPP, we shall have what we need. One thing you might notice as well, in terms of naming, you see that I use short names quite a lot. I mean, we don't really do this at work, professionally, I guess. We tend to use names that are very long and very descriptive and so on. But one of the things I tend to do in my own personal projects is I tend to make the names that are of wider scopes quite descriptive. But the names that are of very short scopes, I tend not to bother. I tend to go for the quick and locally meaningful. And the reason why is because names are really hard. It takes a long time to come up with good names, and sometimes the names have got similar good names have got similar, we end up with a similar string to describe the good names. And because of that, if it doesn't really matter, if all you're trying to use a name is to disambiguate something, like say for example here, I mean, you don't really, you know what this means, right? Physical model, meta-model properties, right? This is quite descriptive. This is the scope of this thing is massive. It could be anywhere in the code base, so you want this to be meaningful. But locally, I don't really want to have to type all of this, so I always come up with a shorthand that locally you can easily say, oh yeah, you mean that. So these names are more like aliases, really. All I care is that the code is very small and very obvious. And we don't, it's not an approach that's very common, unfortunately. Well, I wouldn't say unfortunately, but everyone's got their own way of doing things. But I think I quite enjoy that approach. It's just fast. Whereas in sort of the modern style of coding, we end up typing a lot. Like for example, let's just see how often this chap occurs here. And you can see it happens all over the place. So that's not good. So don't think we need it at that scope, but we do need it at this scope at least. So what we can do then is to say, well, let's just use the short version of this name. Of course, we don't really want to be refactoring everything at the moment, because this is just throwaway code, so we just refactor a little bit, just so where the OCD just can't take it and just tells you that you need to. Sometimes you just have to. And besides, you have to remember that even temporary code lives for a long time, so it has to be sufficiently readable for now. So shall just go through these guys fairly quickly. Now we don't seem to be having too many errors anymore. Okay, now then, probably gonna need a few MMPs here. This guy. So this is just a PPP. Now we need a configuration for the facets. It'd be nice if we could. Properties, facet properties perhaps. Yeah, this guy. Okay, so then, facet properties, PPP. Okay, this is where, and you see what happens when you're refactoring for a while. You get distracted. These distractions are very costly because you make a mistake here, and you're only going to find out where there's some really strange failures in the tests. They are not so easy to explain, sadly. And that's why at this level what you really want to do is to be paying attention to what you're doing as much as you can, to avoid then having to spend a lot of time in the tests. I mean, not safe from that happening, but try to reduce the probability of that happening as much as possible, I think. Because there's nothing quite as bad as trying to understand some random test failure. And you're going to find out that that happened. I'm going to start removing all these fix me's in hacks, because we know this is temp code anyway. So who cares? It is all a hack. And we don't particularly need to know this fix me's. Then when we grab the fix me's, we want to see things that we know for sure really require fixing, rather than some legacy thing that we don't really care about. So programming in a way is iterating through a domain space really, and then as you iterate through that domain space, configuration for the archetype. So I don't know, archetype properties for archetype perhaps that would do. So as you iterate through the domain space, you learn, and hopefully that is then encoded into the source code. That knowledge you got of the domain. What do we want here? Facet directories, so facet properties. A computer directory. And that's what we're trying to do really, trying to make sure that the stuff that you're encoding, the knowledge you're encoding, actually reflects the domain, rather than whatever the first attempt you did at modeling. So we need the postfix for the archetype, so that's going to be computed. And you can imagine how easy it is in the middle of this to make a mistake, very simple mistake, you know, and then having to spend a long time trying to understand where that mistake comes from. Facet directories, right? So for facet directories, probably best thing to do is to just go to the facet properties, I think. That's going to give us ID, facet properties. We should also start using the tying, the new stuff we got on C++ 20 and so on, but we haven't quite got around doing all that. Right, okay then. Now, okay, we might have a problem here. I think we need to do id.value probably, because we don't use strong tabs. Okay, cool. So what did we do then? This was a bit painful, but we seem to have... well, of course, we're not going to commit all of this, because you see here we've done something that violates our principles, which is we first removed the types, and then we updated the code to deal with the removal of the types. And we normally don't do that. Or if we do, we don't actually do that in the commit. The removal of the types is good to reveal that you've really picked up everything that you should have picked up, but you don't really want to commit with the removal of the types, because then it's just a big commit. So you do it in two stages, really. The first thing is you remove the use of the types, and then you remove the types themselves. So now, so locator does not need all this stuff anymore. I wonder what locator needs now. Actually, I never quite figured out how to loop through the available options here. Which then means I end up always having to go back to... Right, so I just need a physical model. That's quite good. And the physical model... I don't actually have a physical model, I don't think. Okay, so where are we then? We are in the model to text chain. And there is a make locator method. Now, who calls make locator? Somebody around here will have a physical model. Hopefully, otherwise I'm going to have other problems. So we have a context. The context. Actually, to be honest, we have a text model, so we definitely have a physical model. Righty. That being the case, let's just go here and say, actually, I don't need all of this stuff. I just need physical model. And similarly here. So just take this guy, and that implies that we don't really need this method anymore, because this is trivial, which then implies that we can just say const formatables locator L, and there we are. Now we're going to have to deal with the ripple of all the different problems. Now, not very clear to me why we're still having trouble, so let's go to our programming area. I wonder if we made a mistake. Yep, a physical... okay, sorry, my bad. When I said that, what I meant was physical. Okay, cool. Here we are. So that creates the locator. Now then, we just have to deal with the ripple effects. Now this is going to be a bit of a problem, because, as you can imagine, this is always what tends to happen with our world. Nothing is quite as easy as you'd like. We have an interface for text transforms. And there we are. And this interface will require all this stuff. a context and enable backend directory. So what we'll do is, for now, as a hack, until we deal with C++, C Sharp. Oh, I didn't mean to do that. Actually, one thing I know. No, I don't really like how Emacs does this. Right, so we will just have to say that this guy here is not supplied. Oh, oops, we broken something here. What was that supposed to say? Oh yeah. Right, there we go. It's supposed to be const? No. We've broken this method somehow. I'll tell you how. Let's have a look. I'm missing something very obvious here. So we need a context, we need a const bool, and we need a text model. I'm not quite sure why LSP is very unhappy with our definition of this method. We'll ask compilation what compilation thinks. Should have worked. Right, so where we think we are now is we think we may have the C++ locator going. And if that's the case, well, of course, now we have to get the test to pass. But whilst all of that's kicking off, we will have a quick look at the C# version of this guy. And hopefully the C# version will have similar parameterization. And hopefully we'll be able to do similar exercise. But as you can see that the compilation is going well. LSP was just a little bit. Sometimes I find LSP gets in a bit of a state and you have to close the file and open it again. Not clear why. So, okay, right, now this means we made mistakes, right? You can see here what's happening is we broke things, broke a lot of things in that replacement. It could be that we broke things because our logic around the new configuration is wrong, or it could just be that we search and replace failed. This is why I was saying we have to be very careful. Now we need to look for clues as to what we've done wrong. And you can see this is a bad break because these diffs are very big. It is actually a really bad break. So what we'll do is, first, before anything else, we just need to look at the diffs. Because maybe something really obvious has gone wrong. So we'll just find an area here somewhere. Maybe area 8. Let's call this the Dogen diff area. And what we'll do is, and now you can understand why I said it's very important not to put too many things in the commit. Because now that things are broken, now we need to figure out what is causing it. And what we'll do is we'll just try to get the diffs here. Right, these are all the diffs we got in the locator. What we really want to do is we want to concentrate on the replacements first. For example, we removed the output directory. There's no good reason for this, I don't think. Oh, actually the diffs are just not... Yes, this is not very nice. The diffs are very confused. Let's try something else. Let's try edif revision. Edif tends to have a cleverer diffing mechanism. Right, so what we want is to get rid of this guy here, and then perhaps make this a bit more even. Now then, on our left side we have the previous version of the file, on the right hand side we have the new version. So there's not a lot to do here. Right, so this diff is much better. You can see it's actually locating things a bit better. So the output directory path is changed, that's not a problem. Then we go through a lot of changes. Make headers path. Okay, cool. And see, it's doing a good job here, Edith. So CPP headers output path. So let's just make sure that. Okay, that looks good. The headers output directory. This is probably going to be something really small somewhere. But now you understand why it is important that we do this, because this validates that the new objects that we're creating have got the right state as well. So if it wasn't just the case that we made a mistake and we were using the wrong things, it actually means that we are not populating those objects correctly. So now you can see why it is important to do these things very slowly, because this is just another step of validation, really. Right, so this also looks good. Remove that, that's fine. Then what do we do here? We obtain a facet configuration, we take a string for the facets, look for it in the facet properties, that looks good too. Archetype properties, we similarly look for archetype properties in the archetype properties container. Don't know why we didn't call this APE, that's fine, we'll do that in a second. Just for consistency. Right, so header file extension is a PPP thing. Implementation file extension is a PPP thing. Postfix for facets. Similarly, locate the facet configuration, compute the postfix, correct. Make project path. Right, these are the sort of things that could cause a lot of problems. So you obtain the provenance to join. That looks good as well. Okay, right, so what we're going to do is, this is just too many diffs, these diffs are too difficult, so I'm not going to really get very far with this, I don't think. So what we'll do instead is this. We will, first let me just do that quick correction on these guys here, just to make sure we use the same convention everywhere. And the facets as well. So I don't mind short names, but I do like them to be consistent, so that I don't have to guess what something means. A bit like a, was it Fortran? Some language where the variable names had meanings. Okay, cool. That's good. Now then, let's just think about this. Let's try to get some clues as to what the errors are. Start with the first error, and let's try to understand what is going on here. So, you can see here, there's a new file now, and the file is Dogen variability helpers adaptation exception. So that file doesn't look new to me. So what I'd say is, if I was to look at that model, say, if I was to go to variability, and let's see, I think we are missing the include directory. You see? Oh, and actually also the facets directory, because it's not doing it under types. Right, so the problem here is very simple actually. We are, the include directory and the facet directory are not being populated. So the include directory is one thing and facet directory is another. So let's start with the facet directory. What would cause the facet directory not to be populated? So the facet directory will be populated here. So let's just make sure we are using the computer directory name everywhere. That will be the very first problem that we'd have. So if I just look for directory name, let's just make sure there is no one what's this? Make project path. Right, this is the first thing that looks suspicious. I suspect this should have been computed directory name. And pretty much everybody else. He's being sensible. Okay, everybody else is being sensible. So let's just have a look at what difference that makes. So clearly the Facet directory and include directory appear not to be populated. Someone is... Well, first thing to isolate is it the case that somebody is using not the computer directory name? Now we've already seen that looks alright, so that's not the problem. Now the second thing is, are we sure that the Facet directory is being populated? So we have to go back to the meta model properties and look for the Facet properties. Waiting for time. 40 minutes. So in the Facet properties, somewhere around here, right, we have the directory name. Now let's just make sure that we are really populating the Facet directory name. So computing the directory name, here we are. So we're supplying some kind of element that has directory name, and so what we're saying then is, if direct name is not empty, so if you have an override, take the override, otherwise take the elements directory name. So what is, so let's just be very careful what we're saying here. So we have, well, right, okay, right, so this is basically the global versus local sort of thing, isn't it, really? So we supply something which we call an element, so something which we call properties, and the idea being that if the properties contain something, then we take the properties, otherwise we take the elements. Now let's just make sure that we're doing the right thing then. So let's imagine I'm a Facet. This is the actual facets as they are. So this basically is just the archetype versus the property, I guess. Archetype instance. And so the archetype comes in, and the archetype here is the FCT. Again, these names are not very helpful. Should really call them with the names that we used before, but that's fine. So the archetype is the FCT. Well, the archetype, no, the meta model element is the FCT. We supply it in, and then we say, if there's an override, take the override. Otherwise, take whatever the meta element. This actually looks pretty sound. That does not look like it's our problem. So either the meta model element does not have the right property there, or because we're not really using the override here, right? So that's fine. So we're not really using the override. So the first thing we need to say is, could it just be that we're not reading the facet directly properly? So let's just look at the facet group. The directory name is obtained here. Get by name fct.value. And presumably what we're saying here is that the directory name should have been populated here. Oh no, actually we're just reading the feature here, so somewhere else. This is just a feature somewhere around here. We're gonna have the facet properties, and there we are. So we're now basically saying, okay, for this feature called directory name, give me the content or the default. Now, okay, right, very good. So now then, at this precise point in time, I would expect to see the name include coming here, and well, whatever the facet name is. So for in this case, types, for example. The reason why I would expect to see that is because if I go back to my facets and I look for a directory name, I'll see a bunch of overrides here. There we are. And these overrides be relative to mas.facets dot whatever the facet name, directory name. And if the facet is called types, then it will take the override. Okay, so this all looks very sensible. So let's just go for our first validation. If we look at the log file, so let's just take one of these tests. Now you should hopefully see what I meant by when you make a mistake, then you spend some time delving to the tests. So let's take one of the tests. Any test will do, to be honest, because it seems like the whole world is broken, but variability seems to be the first test. Let's enable debugging. There's a lot of testing here, so and then let's run the test again. And then we're going to look for the logging of this guy here. So go to our logging area, look for stage, bin, waiting for time, 20 minutes to go. So around here we have logging, and the logging will be, now I always find it difficult to find the logging, to be honest. Variability, let's just look for variability. Could it be this guy here? Let's have a look at the timestamp. No, oh yes, this is because we're in the byproduct, so it's fine. What we really want is log. Right, there we are. So if I now look for orchestration tests, physical model chain, perhaps, September the 18th, October the 2nd, that's us. Okay, right, so now let's look for our target. Okay, there we are. So what we're going to do is we're going to try to understand how the facet properties are shaping up. So what our logging says, if we go back to where we were, the meta model properties transform. We wanted to see what the facet properties look like, which is funnily enough exactly where we are. So let's have a quick look at this guy here. And this looks very good actually, because we interestingly enough we don't seem to be getting a lot of postfixes, but so there is a problem with the postfixes, to be fair. On the plus side, it seems like the directory name is coming through quite nicely. Right, so okay, first bit of validation is we seem to have created the facet properties roughly correctly. So what we're going to do now is we're going to say, well, after you computed right, so let's just try to say, how does the metal, well, to be honest, I would even go as far as saying, probably let's just enable tracing really. Yeah, let's just enable tracing. Go back to our test. And see what happens if I enable tracing. This will slow things down slightly, but so we will enable tracing now, and we will look at this transform specifically and try to understand what is the output of this transform, particularly as it concerns the meta model properties. We're going to generate clearly a very large okay, there's a bit of a problem at the moment. The tracing backend is not set. Let's have a quick look at how these macros work. Oh, actually there's a easier way of doing this as well. Let's not enable this globally actually. Let's enable it locally instead. So okay, right, it's fine. So I don't need to enable it for the whole world, but our particular tests, seems like our this file has got a lot of tests on, and for whatever reason that seems to make LSP go really slowly. Quite annoying actually. It just gets into a bit of a funk, I think. Right, so let's go back to where we were. Variability. Annoying, that seems to only happen to these files with lots of tests. And that's precisely what we're trying to do right now, so not much you can do. Okay, so while this thing is slowing down, right, what we're trying to do then is we're trying to call this method with presumably true here, and then we need to understand who is responsible for setting up tracing. So LSP find definition to this guy. Right, so where is the tracing going on here? Interesting, we don't seem to be setting up a tracer. So right, so the problem is we seem to be creating a tracer somewhere. And this is one of the problems where you have some functionality that you don't test very often. This is not ideal. But I think, sadly, the problem is going to be on the test file, which is extremely slow. Nothing else we can do. We're just going to have to green and bare. It's this guy here that's going to be the problem, isn't it? Right, let's just look at the tracing configuration. Somewhere around here we're going to be basically saying if tracing is enabled, more configuration factory. I suspect the problem is we changed some functionality related to tracing. We haven't updated this factory, so let's have a look at what the guy says. So if tracing is enabled, here we are. Right, there we are. So the error we're getting at the moment is tracing backend is not set. So I suspect we need to say something like backend. That's going to be tracing backend file. Right, if all goes according to plan, we should now have some form of tracing. Well, I don't think we'll be able to get to the bottom of this for this video, I'm afraid, because we already are approaching an hour of recording. Right, okay, so now we fixed the problem with tracing, which is good, but and in fact, to be honest, let's just commit that, I should think. Not that. Let's look for a mock somewhere. This guy here. And let's call these, what are we? Dogen, set the tracing backend in the mock config factory. Right, so that's a good commit. Now let's go back to our logs and let's go to the byproducts directory. In here we shall see tracing coming through. That's good. Now we just have to go through these chains, try to figure out where we are. So we're trying to produce a physical model. We're going to be somewhere around here. The text model. So the model, we're not particularly interested in the model to text chain. We're not particularly interested in writing. But it's interesting that we are, the order of these transforms looks a bit strange. You shouldn't be writing the artifacts before you've created them, really. What is this guy doing? Text. So this is actually doing the text transform, which is fine. It's a bit strange that the order of these transforms is not quite right, but at any rate, let's continue. So the physical model production chain, this is the input to it. Then we have a logical model to text model transform, a logical model to text model transform, the output of that. Then I actually think that this guy here, this is a mistake. Somebody's calling themselves the wrong name. Some transform. Let's just see what RG has to say for it. I suspect. Let's just have a quick look before we continue, because. Okay, that's the right transform. No, okay. Seems like there are no incorrect names, so it really is the right artifacts transform. I'm not sure why you'd write the artifacts before you finish transforming everything, but let's try to worry about one problem at a time, I guess. Post-processing, we don't care about the post-processing. So where are we in the pipeline? We are the model properties transform. Here we are. So the model population chain. So let's look for the model population chain. That's really what we want. Model population chain. So these are all the final physical transforms, though I don't understand why this is at the bottom. These are going to contain a whole lot of text transforms, which is what you'd expect. Probably shouldn't have gone into that directory, because this is going to be like hundreds and hundreds of files. There we are. This is just text transforms. We know what these guys are. We're not going to worry about those right now. But what we really, really want to find is... Right, so there's a model generation chain here inside of text. We're missing the model generation chain for the physical model. There's a production chain. Okay, wait up. Model production chain. Model population chain. I wonder if there's a mistake in the tracing. We don't seem to be tracing the model population chain. Let's try to find some clues from the source code. In orchestration, In orchestration, somebody must be calling the model population chain. So if we go back to the orchestration model, this guy here, let's try to understand what's going on here. So we have a physical model production chain, text model to physical model transform. So the text model production chain, that seems like an interesting place to look. And it converts from a logical model to a text model, and then it calls the model generation chain in the text model. Now I wonder if this guy here is then responsible no, this is already calling the model to text chain. Just missing the point at which the meta model, actually to be honest there's one thing we can do which is very quick. We can easily say meta model properties transform. So let's just say find LSP find references. Sorry, I have noise down coming from downstairs again. No, it's fine. So this guy is called here the model population chain, as you'd expect, and then if I say please find some references for this guy, then I should see it's called from, nope, not that. Right, this is also the apply. Something is missing here. Ah, here we are. Fine. Finally. Geez, this took a while. So the logical model to text model transform is where... okay, fine. Okay, so we're just a little bit lost in the change. So the logical model to text model is where we are doing that. So then, if that's the case, we just need to figure out logical model to text model. This is just the logical transforms. Orchestration, physical model production chain. Interesting, we're missing something here. Physical model production chain, logical model text model transform. Okay, so that's the inputs to that, and this is the output. Now, okay, so this is where things are. Okay, I think I see what the problem is here. Logical model to text model transform. Okay, right. Now then, the logical model text model transform is actually not a transform. It's kind of slightly lying. It's actually a chain. Right, we found a bug, sadly. This is quite annoying. We found a bug that basically the way the chains are linked together is not right. So sadly we're gonna have to yet again stop for a second and yet again remember that we are halfway through a big change. So what we'll do is we'll just let's continue where we were. Locator transform. This is exactly the kind of thing that happens all the time. Sorry, locator changes. Right, so we have to stop here for a second where we are working on the locator changes. We need to build a code generator that actually works. And then what we need to do is we need to go to the orchestration model, and this guy here has to become a chain. And that's why we're having all those really weird, strange problems. Now, I think we have a slight problem here in that we're running out of time slightly. We already are up to an hour. We're not going to get to the bottom of the locators today, on this video anyway. So what we'll do is, instead, is we will I'm tempted to try to just do this one fix. Yes, let's just try to see if we can get this thing to output the right tracing information, and then we'll call that a day of this video. I think it's probably the most sensible thing to do. It's a fairly easy thing to do, I think. That also explains why we're seeing a very strange structure in the tracing. In an ideal world, we wouldn't really be doing any of these things manually, but this is the way things work at the moment. Right, so if I just run all tests here, nothing bad's going to happen. Okay, and now what we're going to do is we're going to rename this guy to chain. It's really a chain. And to be fair, let's have a look at the text model to physical model transform as well, because I think all these things are lying now. Don't really trust them now. I want to see what the physical... This is called text model to physical model. I'm almost certain this will also be a chain. Nope, it turns out it isn't. No, that's correct. Right, so then, the logical model text model transform is this guy here. What we need to do is we need to have both of them side by side, and then we need to just do a crux file and buffer. I haven't understood the difference between rename file and buffer, but I always use this guy, so that becomes a chain. This also becomes a chain, and then we just do a quick rename. Okay, now what we'll see here, hopefully, so I need to just do a convert Dogen dot orchestration dot to JSON to indent this model. And if we go back to Git, we will do the usual fix. Right, so this is the first step. Name the transform correctly. And clearly somebody's talking about this transform. So make sure he's talking with the new name. Right, so first we just name the transform correctly. That should pass fairly easily. Okay, there we are. So orchestration, rename, logical. This is the logical to text model transform. That's easy enough. Now then, the second thing, which is also related, which is the real problem. See here, this is a scoped transform tracer. Really, it should be a scoped chain tracer. And with a bit of luck, might even just be a case of changing that name in running this again. Oh, of course not. Oh, of course. Chain. The reason why we want the transforms to be correctly named is because chains generate directories, and then they put all the files under the right directory. If you don't generate directory, then as you can see there, the files go all over the place and it's very difficult to figure out where we are. Okay. So what we'll do now is we'll say orchestration update chain tracer for logical to text model chain. Okay, now at this point in time we are ready to go back to where we were, and if we just run the tests, a bit of compilation because of course we touched a lot of files. But if we run the test, what we'd expect to see now is that well, we should be able to get to the correct tracing. This will take a while, so. And once we're done with that, we'll call that a day for this video because we are already over an hour. We're trying to keep the videos to an hour and a half, really, because probably already not terribly exciting. I think if you make them even longer, they'll be even less exciting. Thing I did not check is to make sure our nightly is right okay. Probably should have checked. We've just upgraded, did a dist upgrade, and it looks fine. Nightly is right okay. Right, where are we then? Okay, so tests are running. In a second we shall have our diffs. Go up to our logs. Now this should look different. And now, okay, now you can see this is actually making more sense. So orchestration transforms logical model to text model chain. That then has the right transforms, but is no longer the first. Logical model to text model chain. One thing I don't quite understand still is logical model to text model chain. Why are we calling write artifacts in this transform? So now let's look at the code. So this guy here, logical model text model chain, calls this apply. The apply creates a physical model, whatever that means. No transforms there, very simple. And then applies the model population chain to it. So I think we have another bug here. I think the model population chain is a chain, that's good. So I don't fully understand why the model population chain is not showing up under the logical model text model chain. I mean, we must be missing something really obvious here. Let's just look very carefully. Logical model to text model chain. Logical model text model chain, that's correct. Then that then calls model population chain. The model population chain is here, it's also correct, but I don't see any evidence of it being called. You see no evidence whatsoever. And instead, I didn't see the physical transforms write artifacts transform, which belongs to a completely different chain. So there is a very bad bug here in tracing at the moment. It's very bad. Not an obvious one though. So the logical model to text model chain. Here's my physical context. I wonder if somebody did something really silly, like make a copy of the tracer instead of passing it by reference, and then that caused a lot of problems. But if that happened, it would have been around here somewhere, so let's have a look at that then. So logical model text model chain, there literally is no other transform being called around here. The very next one is, well, we have a projector, but that's fine. With the physical model, and then finally we call the model population chain, but there is no evidence the model population chain being called. We don't make a copy of the physical context, it's fine, it's by reference. We don't make a copy of the tracer, so that looks fine as well. So it's not clear why we go from the logical model text model chain, we don't have a model population chain entry. There's something really wrong here, which is not really obvious what it is. Let's first make sure that we are actually looking at the right data. So we have a variability model. This is actually quite a tricky problem. Quite realistic though, this is the kind of things that sometimes you have to face. So this was 1159, that seems pretty sensible. Right, so we know for sure we start on the orchestration transform. So we go back to orchestration now. We have a physical model production chain. Now, that's what we are, physical model production chain for the variability model. In there, we'd expect to see a text model production chain being called. Physical model production chain, the text model. Right, so we'd expect to see a text model production chain being called, which we don't. Right, so it's already starting, the problem's already starting here. So that being the case, let's look at the text model production chain and see what that's got to say for himself. Well, text model production chain seems to be tracing correctly. Again, no copying. The trace is being supplied again correctly. But when we look at it, I wonder if the problem is with the name. Yes, okay, right. So okay, I think I know what the problem is going to be. Problem is we've been looking at the human readable description, but what we have not been looking at is the actual description in area. Okay, fine. This is the problem. I mean, ideally, what we really want is something like name of. So, sorry, let me just explain the problem we got here. So, in languages like C#, there's a really useful operator called name of. And what this enables you to do is, it enables you to say basically, certain things are named after a class or some other existing data element. And so, you want not to actually manually physically type this name, you want to actually use the name of operator to determine the name from the type, so that every time this class changes, the code breaks. And that's really what we need here. We need some kind of C++ version of name of, which, you know, we've seen a few hacks with this, but we haven't seen a language level support for this. Probably should really look into this little library you see here. Because what we have experiencing at the moment is exactly that. What we really wanted was the name of this transform, but instead we hard-coded it manually, and of course it's got renamed at some point, or got copied and pasted at some point, and now all hell is breaking loose. And that's not the only place where this problem is happening, as you can see here, and this is actually quite a problematic thing. For example, right, so now what we need to do is we need to just quickly go through all these transforms and make sure they are named correctly, because you can see how problematic these names can be if you're trying to debug a problem and then suddenly what you think you're looking at is not what you're really looking at. And once more, we need to go back to our Git, and before we do anything else, we have to go back and make sure we locator work, whatever we call it, so that we don't mix these types of works that we're doing here. Right, so okay, so let me just start this again. So codec model set to logical input model set chain, that looks right. Now we are in codec model to logical model. Correct. Code generation chain, this is clearly going to be correct, so old. Actually, we did forget to check to see if they're in the right place. Orchestration is correct. Context bootstrapping chain. Of course, you can imagine we don't usually use tracing unless there's a problem. And when there is a problem, last thing you need is for tracing to actually confuse you even more. Logical model text. Logical model to text model chain. Correct. The physical model production chain. Is correct. Text model production chain. Correct. And text model to physical model transform is correct as well. So that allows us now to believe that orchestration looks vaguely correct. Now then, let's see what the physical model has to say for itself. We just quickly scan through these. I mean, I could easily grep for this, but sometimes you just want to do things manually, I guess. Compute name indices transform. Compute template instantiation domains transform, correct. enablement transform correct. File automation chain correct. So yeah, one thing I find with developers is always that you don't mind doing something by hand if it takes 5 seconds, but then as soon as you do like 3 times or 4 times, you start getting bored, and at that point you just end up having to do things automatedly. So this always happens to me. And so at that point, well, actually we're just going to use grep instead of RG for this. Right, so we have the transform IDs here, and what we really want is a transform ID with a bracket, I think. So here we can very quickly scan everything. Template session domains, compute name indices, write artifacts. So I can't see write artifacts. Let's look at the file. Correct. Remove regions transform. It'll be the transform. Actually, while we're there, can we? Yeah, we can make this one line. Good. At the model properties transform. The population chain. Remove files transform. Some of these are very big, but nevertheless it's good to have it in one line, as you see from the grep. We really should be looking into this name off, because we've been bitten by this a few times already. Meta model assembly. And every time you do get bitten by it, you spend some time fixing things. Formatting transform. Meta model production chain. And merge transform, generate report transform. Enablement transform. Generate patch transform. There's a lot of transforms, as you can see. I mean, we're not going to check the whole world. We probably should, but it's only so many hours in the day. Right, so now then, what we're going to now do is to say, this is a very low risk change. So let's just run the test again. This is very painful, of course, as you can imagine, because you have to recompile everything. That's why the speed of C++ can bite you a little bit. So let's just say orchestration, physical, updates on transform IDs. We're fairly confident that's going to work. How much we can do until compilation is finished. And now we really are running quite late in this video. Right, so to recap, we were trying to debug a problem. We needed to get some tracing data to see what the Dogen was thinking was generating the transform. We're looking for some data in a chain of the tracer. The data was not in the place we'd expect. We found out a whole lot of tracing bugs. We went and fixed those tracing bugs. We then found out another whole lot of tracing bugs to do with naming. We now hopefully think we've gone and fixed those tracing bugs. Tests are passing, so we're now going to go back to the locator. We are going to run yet again the tests, regenerate the tracing data, and hopefully the layout in the directory structure will match the topology or the hierarchy of the transform chains, at which point we shall be able to see the meta model properties data, and then inspect that and try to figure out what Dogen thinks is the state after the transform, which will tell us whether there's some data that is not being populated correctly. And that's going to be in a few seconds while that's going on. Moment we can do while we wait. So let's just pop over to our directory transforms. Once the test run, this will update. And we also seem to have a strange naming bug here. Now you can see clearly we didn't really do a good job here of just 1 second. So fix name of configuration tracing file story. This name looks correct. Now we don't really care about this right now, so we can just backlog it and worry about it later. Now for the last hour or so, see, this is not very good timekeeping really, so what we should have done really, in fact we haven't even clocked that much. So from 9:51, probably this is a bit of a guess now, but it's good to try to get it as close as possible to reality. So I would say probably for the last hour, maybe, we've been actually dipping the goats of tracing. So tracing of orchestration chains is incorrect. We still can't somehow tag things in org mode for some reason. Whilst looking for tracing information, we notice that the layout of directories is not correspond to the chains in source code. Fix the transforms as required. I know this doesn't really add a lot of value, this comment, but you see what I mean. And then we probably started this around 11 something or other, so that we clock time for the right stories. Now then, so we enter the physical, let's just try to see where we are. We enter the physical model production chain. In there, we expect to see a text model production chain. And we do, and in the text model production chain, we then expect to see a logical model production chain. Logical model, text model chain, that's correct. And in there, we expect to see the model population chain, so that's correct as well. So I'd say that this story is now done. And I'd say that we are now back on this story. This is how we should clock time. We are just not very disciplined, but we should really work hard on that. Now then, so just before we go, let's just have a quick look at what we think is the output of the model population chain. That's the input. And we really know that this is the guy we're interested in, so we're just going to JQ this guy. It's going to be a pretty large dump, because as you can imagine, we are looking at the physical model. It's a pretty big thing. We only care about the metamodel properties of the physical model, so we'll be able to trim it down very quickly once we have an idea of how it looks like. Hopefully this will not be too big. 13 megabytes of JSON is not too bad. JQ normally is very quick. The problem is not so much with JQ, is Emacs JSON mode doesn't seem to like very, very large files. In certain cases it's better to actually try to do trimming on the shell, generate a second file, and then see that in Emacs. But there we are. So what we'll do now is we need to figure out, see, as you can see, Emacs is already slowing down. 25 megabytes of JSON. Right, there we are. So all we need really of these 25 megabytes is this guy, so we'll try that instead. This is much, much smaller, which helps us. And now here we can easily look for the facet properties, and there we should now see that, look for something like types, or even serialization. And see, these are all looking very, very nicely, very correct. Some of these will be C#. Ah, there's types. Types for C#. Ah, look, there is a problem here. We don't seem to be updating the computer. Oh no, yeah, sorry, it's correct. Let's just look for types in C++. All of them are looking quite correct, if I'm honest. But we don't seem to have all of them. Don't seem to have seen types, actually. Some random reason. So let's start again. So there's templates, Visual Studio, serialization, test data, ODB, types. No, C#, test data hash, types. Here we are. And the computed postfix is not populated. Ah, but the computed directory name is populated. So that's correct. Okay, all of this to say, we think that the types directory name should have been in the right place. Okay. So we will conclude at this point in time that we've done enough work for the video, which is to continue the work on locator. We shall do a push because we've done plenty of work already. These are just our usual backlog grooming. But we'll leave the outstanding work on the physical model as it is, and we'll just push all of this to all of our mirrors. And there we are. Okay, this is enough for this current video. Thanks for watching.